Alright, so this is going to be our next notes in algebra. This is on the slope-intercept form. So we've been talking about linear equations. You see here, this has something to do with that. And you remember a linear equation is some equation that when you write it out on a coordinate plane, it will be able to form a line. And you can see this line right here. Okay. There's certain ways that mathematicians categorize or write an equation. There's lots of different ways. And we're going to look at this slope-intercept form. Usually there's a little dash in there. Okay. And so the standard form, they call it like the general way to write the slope-intercept form, is y equals mx plus b. And you should kind of see some things that are common to linear equations. One of them, it has a y and it has an x. And what these refer to are any points within the coordinate plane. Because if you remember, if you look at this axis here, this is the y and this is the x. And if you take this point right here, we could figure out maybe it's 4, maybe 4, 0. Because on the y it's at 4, on the x it's at 0. So we could label this point with two coordinates, 0, 4. 0 is always the x is first, and then 4 for the y, which is second. And it's a standard way that you write them. Okay, so then we can use these coordinates in this slope-intercept form. We'll look at that in a minute. Now the m stands for something else, and that is slope. And if you remember, we talked last unit in 3.3 what slope was. And slope equals rise over run. And rise is talking about the change in y. And run is talking about the change in x. So really we're talking change in y is from this on the horizontal, and change in y is talking about in the vertical. The change from one point to the next. Okay, so and we can figure these things out, y and x, and we can really just pick 2 points and plug those into this equation. So for any line we had, we could like graph like this point perhaps, and this point would be equal to 2 because that's where the x is, and then 2y, so 2, 2. We could actually use that and plug it into this equation if we knew the slope, and we'd have to figure out the slope. And then we just have to find this b here. What it represents is the y-intercept. That's what that stands for, the b. So when we go back and look at this, we can then figure out what each one of these things means for this slope-intercept form. So we have these y and this x. These are the 2 points. You can use any 2 points you want. And then the m equals slope, and then b is the y-intercept. So when we look at any of these a line, we just need to find where it crosses the y, 2 points on that line, and then what is the slope, and we can convert it into this slope-intercept form. So let's look at an example. So for this one here, the information we have is the following. It says write an equation for, and let's say in slope-intercept form, for a line. It should be a line. So for a line, make sure you add that. So we want to write an equation for a line. This is a line. We want to write it in the slope-intercept form, so we're going to write in y equals mx plus b. And it tells us it has a slope of 3/4 and a y-intercept of -2. So then if we're going to write that, right, so we look at this form here, y equals mx plus b, we could then plug in. So we don't know any points there, that's kind of a problem, but we could plug in the y-intercept -2 for b, so that would go right there. And then we could plug in the slope right there, but then we would still need some lines as well. But let's go ahead and plug this in, or some points, I'm sorry, not lines. We'd need the x and the y point, okay, and we could solve for one or the other. And so let's do this first, and then we'll talk more. So for the y stays, we don't know what it is, then the m would be 3/4, then x, and then it would be plus a -2, okay, And you'd want to rewrite this. We want to get this positive because plus and negative 2 is really saying minus 2. So if we were to rewrite this, it would be y equals 3/4 x minus 2. And then we have the slope-intercept form. And then we can solve for something we don't know. So if we want to know if x is on this line, this would be a specific line, and we could definitely graph it here, and I'll show you that in a minute. But we could plug in x and figure out what y is, and we're going to kind of do that in a minute. That's how you do this slope-intercept form. You can write this. All you need to know is what is the slope, and that would have to be given. You can also figure it out if you have points, and then you need the y-intercept. Okay, so that's that first part. There's an example. Okay, so if we then looked at, so how could we also, we have this equation, right, and it's y equals 3/4 x minus 2. So whenever we have this equation and we want to start writing a line, we know one thing. It crosses the y at -2. So then we fill in our graph. Here's -2, and it'd be crossing the y. So on that line where x is -2, I'm sorry, y is -2, x should be 0. So that's that point. We have that one point of the line. But then we also know that the slope is 3/4. So we know it's rise over run, so it goes up 3 and across 4. And we can just do it. You can really do it either way. You could do the across and then the up. It doesn't really matter. But we know it's 3 up and 4 across. So then we can plug that in to go from this point, 0, 2, and we go up 3. So we go 1, 2, 3. Oh, wait, 1, 2, 3 would be here. And then we want to go across 4. It'd be 1, 2, 3, 4. And then we have that point. Right? And then we can then draw a line, and we see the line for that equation. Let me grab a ruler here. Make sure I have one. I do. This. So if I just use my ruler here, I'm a little bit off, but it's pretty good. Okay, so then we have that line, and that tells us this is that line. So then we could label it y equals 3/4 x minus 2. And then if we want to double check our slope, we know it's 3 up and 4 over. So we could see, is there another point on here where, well, the next, if we did the 3/4 up and 4 over, would it also still be on the line? So we could do it. So we go 1, 2, 3, 1, 2, 3, 4, and it does. It's right on the line. Okay. And we could keep doing that. We could go 1, 2, 3, 1, 2, 3, 4. That would be another place we could connect this together then, and the line just keeps going. Okay, so that sounds good. That's how you use that slope-intercept form. It's a good example for you. And so if we keep going, there's another possibility you could be facing, is what if it's not in slope-intercept form? You have to rewrite it. Okay, so you just have to use your rules of algebra to rewrite this, and I'll just review that with you, and you can just follow along with me. So here, what we want to end up with, if you remember, is y equals mx plus b. And we want to get y by itself, keep it on this side. We probably want to move the x over, right? So we're going to, and then we want to get the y by itself. So then what we're going to do here is we're going to minus 3x. We're obeying the rules of algebra. So we're going to do the same thing to both sides. This then cancels. This becomes 2y equals 6 minus 3x. Okay. And then we might want to realize we have 6 minus 3x. And really we want x before b. Okay. So we probably want to move that at first. So we'll go 2y equals negative 3x, and we're just adding it to 6. So then we have that. Then again, we still need to get it by y by itself. So then we divide by 2, everything by 2. Right. This will cancel. We'll then have y equals negative 3x divided by 2. So we'll just rewrite that. 3 over 2 times x. and then it's 6 over 2, and that would be 3. So then that would give us our slope-intercept form. It tells us it has the y-intercept at 3, it has a slope, a negative slope of 3 over 2, and this is y. And then we could plug in points, and we could even graph this. So if we wanted to graph this, let's go ahead and do that so we get another example of that. So we have this graph here. Let's rewrite this equation. Give me a minute. Write it up top here. Y equals negative 3 over 2 plus 3. So then that's our equation, right? Slope-intercept form. So we know we start at 3. So that's going to be our y, right? 1, 2, 3. So that's our first point, right? Right there, 3. That comes from this. That tells us what that is. And then we know the slope. And this is going to be a negative slope. So the negative slope is going to be wanting to go down from left to right. So this is going to be something along this lines here, right? So then, and we know this is your rise, and this is your run, okay? And then, but we know the rise is opposite, so it's going to be down. So we're going to go 1, 2, 3. We go to the origin here, and then we're going to be going over 2. So 1, 2, right there. Okay, and we kind of know that it's going to be this way, right? Because we have to remember it's a negative slope, so it's going to be down. If we went the other way, if we went down 1, 2, 3, and over 2, then this would then be a positive slope. Okay, so we know which way to go by remembering what kind of slope it is. It's a negative slope, so the line has to be going down. So then we have these points, right? And then we can just use a ruler, and we can write this line out, connect the 2 points, and we know the line. And there we go. That's how you do that. My line isn't perfectly on these points, but do your best on that. There's some skill to that. You just have to practice that. Okay. So that's kind of how you rewrite it. So you may start off with something like 3x plus 2y equals 6. You rewrite it. You then have this right form, and you can then take that form, plug it into a graph, a coordinate plane, and write it. Okay, and each one of these, again, the b represents the y-intercept, m represents the slope, and x really represents 2 points on that slope. And we'll learn about how we use that at a later time. Okay. Now there is one exception we want to talk about to the slope-intercept form, and that is the fact when y, there's no x in the equation. Something like y equals negative 3. When we see there's no x, that tells us that the slope is 0. There is no slope. And really that means it's a horizontal line. And also we can understand once we look at the graph, there's an infinite number of choices for x. So let me write this, and maybe this will make some sense to you. So if I just have a basic, I won't use the graph paper for this one. And then it's y is negative 3, so we're going to go down 3. And then we'd have a point here. And we know it's always, so whatever x is, y is always negative 3. We'll put a couple points in. So if y was negative 3, x could be 1, x could be 2, right? So then we look, and we even go negative, it can be negative 1. And then you kind of see when you make the line that what it's really showing us here, and these points might be a little bit off, but again, it's showing us a horizontal line. And when you have a horizontal line, there's no slope, so slope equals 0. Okay? So keep that in mind when you're doing these. When you see something with just y equals, you know it's a horizontal line, and that will have a slope of 0. Okay? And I think we can do one more here. One last thing is, so let's say you have a graph, and we want you to take that graph and turn it into the slope-intercept form. So we could do that with the following. So the only thing we need to, if you remember the equation, is y equals mx plus b. So we need the y-intercept and we need the slope. Okay? And then we can first find the y-intercept. It looks like it's right here, right? So we go 1, 2. So y-intercept is equal to -2. And then the slope. And what we can do is we can pick out two easy points. Okay? And we'll pick this one because it's right on the line. Okay? So then we can figure out the slope by comparing these two. So if you remember, in the one lesson we did slope is y2 minus y1 over x2 minus x1, right? And we figure out these points. We know x here is 2, and then y is 0 because it's on the 0 point of the y. And then here, this point, we have -2, it's 0 for x and -2 for y. So then we can take those points. We'll make this 2, we'll make this 1. So then we plug them in. It's -2 to plug it into this. -2 minus 0 on the top. Then for x, we would have 0 minus 2. Okay, and then we do the math. And you remember, we're gonna 0. It doesn't matter, right? So it's gonna be -2, and then 0 minus 2 is -2. Okay, it's gonna give us -2 divided by -2. It has a slope of 1. So for every 1 you go up, you go 1 over. So we could check it and see, is that true? So we go up 1 over 1, it's on the line. Up 1 over 1, it's on the line. We can just keep going. Up 1 over 1, it's on the line. So that works. So that's the process. You find where is the y-intercept on the line, and then you know what that is. And then you figure out what the slope is. Then you can take it and rewrite it into this y equals mx plus b. So we know y is going to stay the same. The slope is 1. We could write 1x, but really, if it's 1, we don't need to. So it's 1x, and then it's a -2, so we won't put plus. It's -2. And then we can rewrite this. We don't really need the 1. It can be y equals x minus 2. That is the slope-intercept form for that line. And that should do the notes for you. Make sure you add these to your notebook, and let me know if you have any questions in class. We'll go over these practice problems when you get in class. See you tomorrow.